Alright, in this video I'm going to go through the 6.1 to 6.4 quiz review. On the first two, I want to use the graph to write the function in the form f of x equals b to the x. So I think there should be an a here. There's a typo. What I'm going to do is I'm just going to rewrite these points in a table of values. So I have -1, 1/2, 0, 1, 1, and 2. So I want to go ahead and put this into my calculator. I go stat, edit, and then if I need to clear out my list, I arrow up to the L, press clear, arrow back down, and then it deletes it all. So again, do it here. Then I want to do -1, 0, 1, then 1/2, 1, and 2. Then I go second mode to go back home. I press stat. This time I arrow over to calc. I want to choose the choice that has exponential regression. It's 0 on my calculator. It might be a different number on yours. Then I arrow down to calculate and press enter. And so this one is going to give me f of x equals 1 times 2 to the x exponent. Same thing for the next one. I want to plug it into a table of values. So I have -1, 0, 1. And then that's 1/8, 1, 8. If I go edit my list, my x values are the same. I go second mode to go back home, stat, calc, choice 0, all the way down to calculate. So this one gives me, what's this, f of x? Number 3 it says the value of a rare coin in dollars can be approximated with this model, where t is the number of years since the coin was minted. Tell whether the model represents growth or decay. So this number is larger than 1. It is exponential growth. Identify the annual percentage increase or decrease in the value of the coin. So I'm going to take my growth rate, subtract 1, which gives me 0.06, and then multiply by 100 to turn it back into a percent. So this is 6% increase. The original value of the coin, this one I want to plug in, I don't have to plug in anything. That is this value, so 25 cents. Estimate when the coin will be 60 cents, so I want to graph y equals 0.60, and then that equation, y equals 0.25 times 1.06. And then I'm going to change that t to an x, so I can graph it on my calculator. So 0.60, and then 0.25, 1.06 to the x exponent. And then I am going to change my window. My largest number here is less than 1, so I'm going to make my y min a lot lower. I wanted -10. I'm going to make my y max 2. And then I'm going to graph this. So then I can see that my two lines are crossing. I go second trace, choice 5, because I want to see when they're crossing. I press enter once, enter twice, enter a third time. And this gives me 15. So 15 years after it was minted. Then I want to rewrite these functions in the form y equals a to the 1 plus r to the t power, or y equals a times 1 minus r to the t power, and then state the growth or decay rate. So I just want to, for these ones, type in the number to, I can rewrite this. So I have 3 to the 1/2 power to the t, which is going to give me y equals a times 1.73 to the t. And then I want to split that up, so I want to subtract 1, which gives me 0.73. So this is going to be y equals a times 1 plus 0.73 to the t power. I'm going to do the same thing for number 5. So that's going to be a times 5 to the 1/8 to the t power. Gives me 1.22. Oh, I want a growth or decay rate. So on this last one, it's 73%. So this is going to be y equals a times 1.22 to the t. So if I split that up, it's going to be y times a plus 1. Y equals a times 1 plus 0.22 to the t, just 22%. And then the same thing for number 6. I want to split up the part of the the base with my exponential. So it's going to be a times the 0.4 cubed to the t power. So 0.4 cubed is 0.064. And then I want to subtract from 1, which gives me 0.936. So it's going to be y equals a, 1 minus 0.936 to the t power. This one's minus because that number up above was less than 1. And then this is going to be 93.6%. The next one tells me I'm depositing $3,000 into a bank account that pays 1.25% annual interest, compounded semi-annually. So that is twice a year. My interest rate is 0.0125 because I divide by 100. How much does it have after 4 years? And my initial amount is $3,000. So plugging in, I'm going to have y equals 3,000. 1 plus 0.0125 over 2 to the 2 times 4 power. This one is this formula because it says the word compounding and it gives me a word other than continuously, so I want to use the one with n. Then from here, I just want to type this all into the calculator. Which gives me $3,153.32. Oh. That wasn't the question. A wants me to write a compound interest model A to find the balance after 2 years. So plugging everything in, it's going to be A equals 3,000 times 1 plus 0.0125 over 2 to the 2t power, because I don't know the time. Then it wants me to find the balance after 4 years, so that's the work I just did. So I'm just going to draw this arrow right here. That's $3,153.32, my bad. How much interest does it earn after 4 years? So I'm going to take this number I just got for part B and subtract the original amount I put in, which was 3,000, which gives me $153.32. So all of that is interest. How many years will it take to have 5,000 in my account? So I want to graph the two. So I'm going to have y equals 5,000 and y equals 3,000. 1 plus 0.0125 over 2 to the 2x. I'm typing this into the calculator. So I'm going to type in my two equations. On this one, I want to change my window. I'm going to make it 5,500 for my y max. I just needed something over 5,000. And then I go second trace 5 for intersect, enter, enter, enter 3 times. And it gives me 40.99, so 41 years. These ones want me to simplify my expressions, so on here I just add my exponents. That gives me e to the 7th. Over here, I want to split this into 2 parts. I'm going to have 12 over 36 and then e to the 5th over e squared. 12 over 36 simplifies to 1/3. And then for my e's, I subtract and I get e cubed. So I could have also written e cubed over 3. Both are right. On number 10, I want to distribute my exponent to my 2 separate bases. So then it's going to be 3 squared times e to the 6x, because I just multiply exponents and I already have one. 3 squared is 9. Okay, these ones want me to use the properties of exponents to rewrite this. This is kind of like what we did on the front side, so I just want to rewrite the part that has the e into my calculator. So if I go e to the negative 0.5, this gets me, it doesn't say how many decimal places, I'll do 3. So this is really y equals 0.607 to the x power, and then I want to subtract that from 1, so I'm going to do 1 minus 0.607, which gets me 0.393. So y equals 1 minus 0.393 to the x. It wants me to have the percent of change, so I just multiply that decimal by 100 to get 39.3%. Same thing over here. I'm only looking at the part with the e. So negative 0.2. This gives me 8.18, or 8.18, 8.19. So I have that 2 out front, and then 0.819. Then I want to subtract 0.819 from 1, which is 0.181. Which is 18.1%. And then same thing here, type in that part. Which gets me 1.822. X, not t. Then I want to subtract 1 from that to get my growth rate, which is 0.822. Which is 82.2%. Okay. My next question says I invest $4,000 in an account to save for college. Option 1 pays 5% compounded semi-annually. What would the balance be after 2 years? So this is P. My R is going to be 0.05 as a decimal. N is 2. Time is 2. So plugging in, I'm going to have 4,000 times 1 plus 0.05 over 2 to the 2 times 2 power. Which gets me 4,415.25. Option 2 is compounding continuously. So this key phrase means I want to use the formula that has e in it. So it's going to be 4,000. My rate here is 0.045. So e to the 0.045 times my time, which is 2. Which is $4,376.70. Okay, these ones want me to rewrite in exponential form. Remember, my log base is my base. This number moves here to become my exponent, and then 8 switches sides. So basically I'm just switching sides. Then I have this one. This 7 right here is my base. This one becomes my exponent, and the other 7 is what it equals. 5 becomes my base, 2 becomes my exponent, 25 becomes what it equals. These ones are going the opposite way, so I'm going to write the word log, base 4, because it's my exponential base, 16 and 2 switch places. So next one is log base 5, 1 and 0 switch places, and the last one is log base 6, and then 1/6 and -1 switch places. These ones want me to simplify my expression. Because my base and my exponent are inverse operations, those cancel out, and I'm just left with x. On 22, I want to rewrite 64 as a power of 8. So that's really 8 squared. So I can rewrite this as log base 8 times 8 to the 2x. The log base 8 and the 8 are inverse operations. They cancel out. So I have 2x. Same thing over here with the 64. I want to rewrite that as a power of 4. That's 4 cubed. And then I had the 3x there. So really I have log base 4, 4 to the 9x power, those cancel out, and I have 9x as my answer. These ones want me to find my inverse operation, or inverse of the function. So first step, switch x and y. Then this one is ln, so that means I want to use e as my base. So I write e to the x, and then e to the ln 3y. So these two become my exponents. On my left side, e and ln are inverse operations, so they cancel out. So I have e to the x equals 3y. I want to get y alone, so I divide both sides by 3. And I get y equals e to the x divided by 3. Same thing over here on 25. I want to start off by switching my x and y. So the first thing I want to undo here is that 6. I'm going to subtract 6 on both sides. I have x minus 6 equals 3 to the y power. Now I want to get rid of my exponent. So I'm going to rewrite these as log bases. So I have log base 3, x minus 6 in parentheses. That does not look good. And then equaling log base 3 of 3y. Sorry, my hole is like right there. Log base 3 and 3 cancel out, so I have log base 3 of x minus 6 equaling y. Okay, this one wants me to say the transformation represented by g. I'm adding 3 at the end, so this is shift up 3. This one is subtracting 1 in the exponent with the x, so that is shifting right 1, because remember it's opposite the sign with the x. Over here I have a negative out front, so that is a reflection. And then I'm adding 2 in my exponent, so that's shifting left, because it's opposite 2. Over here I have a 2 out front, so that's a vertical stretch of 2. I want to be careful, this original function has a negative, so this negative doesn't do anything. And that 5 is going to be a horizontal stretch of 5. Not stretch, shrink. Opposite of 1/5. I don't think we did horizontal stretches, but if it's there, this is what it is. Numbers 30 and 31 want me to write a rule for g that indicates the transformation of f. So this first one is a reflection in the x-axis. So that's going to be a negative in the exponent. So I'm going to number my steps. So the first one is a reflection in the x-axis. I'll write this part later. So that's going to be 3 to the negative x. Then my second step is a translation 3 units left. So that is adding 3. And then my third step is going 1 unit down. So that's subtracting 1. So my final answer is g of x equals 3 to the negative x plus 3 minus 1. Number 31 is going down, followed by a shrink, and that's it. So my first step is log base 8 of x minus 4. And then my vertical shrink is affecting both of these. So I have 1/2 times log base 8 of x minus 4. Distribute that out. So this is g of x equals 1/2 log base 8 of x, and then minus 2. Because I distributed that. This one wants me to graph the function 4.5 e to the negative, I think there should be an x right here. So I'm going to graph this on my calculator and then sketch it on the paper. So 4.5 e to the negative 0.5 x. And then I'm going to go to zoom because my window's all wacky. And I want to fix this, so I'm going to press 6 to make it my original. So it looks something like this. This is getting smaller as I go on, so it's decay. My y-intercept is the number out front. This is 4.5. My asymptote is the line it gets close to. This is y equals 0. My domain, it seems to go left and right forever, so this is going to be negative infinity to infinity. And then my range is 0 to positive infinity because it keeps going up on the left side. Okay, my last question says, my grandparents invested money in a college savings account when me and my brother were born. The balance A in dollars after t years can be modeled by this function. The graph shows, I think this t should be right there. The graph shows the balance in my brother's account over time, which has the greater balance after 18 years. So first thing I'm going to do is I'm going to do my brother's balance after 18 years because I just look. So that is, these boxes didn't come through well. 16, 17, 18, a little less than 19. So I'll say my brother has 18,500. And now I want to figure out how much I have after 18 years. I'm going to plug into this equation. So I have 150,000, or 1,500. I'm going to do 0.5 times 18. So I have 3,689.40. Okay, so I have $3,000. My brother has $18,000. So my brother has more money.